So I'm Elaine Wilcox-Cook. I'm a data analyst with Insight, which Kelsey just explained, so I won't review what Insight is. And I'm here to talk to you about Python PPTX, which is a Python package for programmatically creating slide decks. The way that it works is using a slide master where you'll have several slide layouts, and it pulls those existing slide layouts from the slide master and populates those to create slide decks. And also this presentation was created using a slide master and Python PPTX, so you can see that it's like very easy. Graphic design is not my passion, so please don't please don't judge Python PPTX on the quality of this presentation. So why would we use this? So we just recently used this for a project that I also can't get super in-depth about, but it involved the creation of literally thousands of slides across multiple slide decks, and they had previously all been created manually. The slide decks were very similar. For example, imagine if we were doing a focus group at many different sites across the country and we were all using the same questions, and we wanted to be able to talk about each of those focus group sites. You know, the slide decks would be identical, but they would contain different data. So the really nice thing about this package is it's very good at automating at 3 different levels. One is repetition of slides that are similar. For example, if we want to, for every question in this focus group, have a slide that's a bar chart of the results and then a table of the results and then maybe an image from the focus group. This is very good for creating that level of automation where everything is formatted exactly the same across that sequence. And then similarly, we want the slide decks to be the same from slide deck to slide deck, and we don't want someone to have to manually create them. This is very easy. You don't have to do any sort of scale up to create the same slide decks. And then additionally, if we want to do this next year, we can just input the updated data and run it again, and it'll do it for everything, as opposed to everybody starts from scratch and manually recreates all those thousands and thousands of slides. The other thing that is near and dear to my heart is that it's so thrilling when you're about ready to send something out and you get told, actually, could you change this one little thing in every single slide? Can you change it so that all of the bar charts actually just in these thousands and thousands of slides has an extra decimal place? Well, with this, that is super simple. You can just say, yes, no problem, and it really is no problem. You can just add that in and change it. So that's something that's very appealing to me. So how do you actually create content? So like I said, the slide deck master has these like layout slides that you can pull in, and if you don't have one, like if you didn't create a master slide deck, they have a default one, but like why would you do that? You should create your own that's nice and formatted. So these layouts have placeholders that can be pre-formatted to a certain degree, and you can insert content directly in there. You can also just insert content into a slide, but I didn't do that, so I'm not going to talk about it. So when I say placeholder, what I mean is content that can be inserted, such as text boxes, which is what is contained on this slide, charts, images, tables, and more, but I'm only going to talk about what I did. So this is what it looks like when you have an unpopulated slide with placeholders present. I guess when you display it, you actually can't see it, but if it's not in a presentation, it looks like this. I didn't leave it, so it actually is minorly populated because I didn't want to give myself a heart attack and just see a blank slide in the middle of my presentation, but this is what it would look like. This is a chart placeholder. As you can see, it's just this like little box that says click icon to add chart. So this is what I was talking about when I said that you can pre-format things in PowerPoint to a certain extent. So if this were a text box, we could control whether or not it automatically starts off being bulleted, what its automatic font default is in terms of size and color. But as a chart, this is all that it looks like. So we can't set defaults of like, oh, this is how I want it to look, because this is all we have to work with. And then this is that same slide from the same slide layout, but inserting a chart. So this is what it looks like if I just say, here's some data, put that in a chart, here's the x-axis, here's the y-axis. I didn't specify what font to use, I didn't specify what colors to use, those are just the ones that automatically come with the theme. You can add things like axes, labels, and a title for the content, but I wanted to show you like, this is exactly what it looks like without having added anything. So charts are pretty straightforward. They're pretty easy to work with. There are lots of options that are very easy to add stuff with. You can either have it go with the default colors that are part of the presentation, or you can set your own. Tables, I do not love tables. You have to fill them up cell by cell individually instead of just like creating a table and inserting it. But they're not that bad. It's just sort of annoying, like, to create one because you have to fill every single one of these cells. Like, this is 00, 01, 02, etc. But this is an example of something that we did where, for example, we wanted to populate a table with what is everybody's first, second, and third choice color code. So this is the type of thing that can be done really easily in Python PBTX. Images, this is a very meta slide. This is, I inserted an image of the code that I used to insert this image. As you can see, this is the most simple and probably my favorite type of slide to do because it's literally just create a slide, here's the title, write something in the title, here's the image, put something in there. And text is a little bit more complicated. So text is like, what populates the text box is in two categories, a paragraph and a run. So a paragraph is all the text contained before a line break. So each of these bullets is a single paragraph. And a paragraph is always composed of at least one run, and a run is just like a chunk of words. So as you can see in my very beautiful last bullet, you can create as many runs in a paragraph as you want, and you use it to split up how you're formatting the text. So you can vary the font size and the color and whether it's italicized or if it's bolded. So also, obviously, you can mix up the type of content. You don't only have to have a slide that's just a text box or that's just an image. I just thought that that was easiest to present that. So the pros and cons, it's really good for automation. Like I said, I certainly would not want to manually create thousands of slides manually. I would be very sad if I had to do that. And with this, it was pretty easy. It's really a very simple package. It's very easy to learn. Our team picked it up in just like a couple of days. It's not bad at all. It's also very flexible. Like if you can't get it to do exactly, like if you, because you're able to work both with the master slide in PowerPoint and also the Python programming, like if you can't do something in one of them, you can do it in the other and vice versa. Like if it's just faster to create the default font in like the PowerPoint layout slide, you can just do it that way. So the con, and this was the biggest downside for me, is it's not good with static slides. So all of these slides, like I said, I created these in a program, but if I wanted to add, say, 40 slides that are always going to be the same every time in the middle of the presentation, this package is not good with that. It's okay if you need to have a lot of static slides that are going to be the same every time at the very beginning of the presentation because you can just insert your slides after that, but for some reason you can't do them in the middle or at the end. So you would just sort of have to work around that. And the other thing is there are some things that I just couldn't get it to do. Like none of these tables have horizontal lines in them because it just can't do that, which is sort of hard, also something hard to explain to a client. Like, can we just not? It would be very hard, and I don't know how to do that, and I don't think that we can. So, yeah, in conclusion, I think it's a pretty good package. You should check it out if someone wants you to make thousands and thousands of slides. Any questions?
I can think of lots of applications for this. Lots. Anyway, thank you. Is Betty Hashima's here? Okay, good. I hope I did not mess up your name. Okay. Is it, you don't want to use this one that's on here?
Yeah.
Because I have this one.
I think I updated that. I said
You have it updated?
Yeah, but
okay.
It's not
B2?
there.
I'm going to save it to here. There you go. You want presentation mode? Or you want to see the, okay. You know, show it like this, and then you can just look at this over here, okay? Several people have been doing it.
Yeah. Hello, my name is Mehdi Hashemipour. I'm a data scientist with the Bureau of Transportation and Statistics. I've been involved in several machine learning, deep learning, remote sensing, object detection projects at BTS. And this project is we have started to taking a look at the commodity flow survey, which has been designed 20 years ago, and we are looking into seeing if we can redesign the sampling approach that has been done 20 years ago, and we apply new methods to basically run the CFS 2020 in a completely new approach. So a little bit about the commodity flow survey. Since 1993, the Census Bureau and Bureau of Transportation and Statistics have partnered with conducting the commodity flow survey, which provides important statistics about the movement of commodities in the United States. The goal of commodity flow survey is to make reliable estimates of annual total value of shipments, annual total tonnage of shipments, and annual total ton miles of shipments. We want to make these estimates for various areas of interest, like geographic origin of shipments, geographic destination, industry of shipments, industrial establishment that's making these shipments, commodity shipped, and mode of transportation, and there are some other variables as well. So the target population in the frame that we basically run in the first stage of the sample consists of establishments that are likely to ship physical products, likely to be in business in 2017 that we ran the CFS, and for which we have data in the business register, the database that basically we construct the frame. So shipper survey, the maximum sample size of the first stage of the sample couldn't be over 104,000 establishments due to the fixed budget constraints. And these industries are including mining, manufacturing, wholesale, and retail. So the sample design has 3 stages, the current sample design. In the first stage, we sample the establishments. The second stage, we sample weeks, and in the third stage, we sample shipments. So it would be too burdensome for the respondents to report on all of the shipments they made in the year, and that's why we perform the second and third stage of sampling. We only ask about shipments made in some of the weeks in the year, and we only ask about some of the shipments made in those weeks. So we use origin industry cells because we are interested in estimates for these cells, but more importantly because we are interested in estimates for origin commodity cell, and industry is a proxy for commodity. Using origin industry cell as a strata allows us to control the sample size for these cells, and thus we control variance of estimates for these cells. So in this exploratory research, we applied the optimal stratification and allocation methods. Sorry about that. Based on the genetic algorithm and simulated annealing in a CFS-like scenario. The objective for this research is we are exploring if using these methods we can minimize the total sample cost while satisfying the target coefficient of variation CV constraints. So experimenting these methods by using domain variables such as different CFS areas and industries may result in completely different sampling design for the next CFS. So in computer science and operation research, a genetic algorithm is a meta-heuristic inspired by the process of natural selection that belongs to a larger class of evolutionary algorithm, as shown in this diagram. Genetic algorithms are a class of probabilistic optimization algorithms and are commonly used to generate high-quality solutions to optimization and search problems. The genetic algorithm is used to optimize the combination of a strata and find the fittest CFS design that minimize the total sample cost and CV. So in the evolutionary cycle in overall, samples are selected from the population to be parents to crossover and produce offsprings, also known as selection operator. Parents are selected according to their fitness. The main idea is that a better individual gets a higher chance to be selected. In the next step, we choose a random point on two parents that then split parents at this crossover points to create children. Like the nature, the mutation happens and we replace the next generation with the new offspring. And evaluate their respective fitness. We repeat the cycle of genetic algorithm with the new generation as the current until the optimum desired condition is achieved. So in CFS, optimal stratification and allocation based on genetic algorithm explores the set of all possible stratification based on atomic strata, which is the most detailed stratification derived from the Cartesian products of all auxiliary variables as the solution space. The objective function minimize the total sampling cost of sampling per unit in this specific case be set according to the effort associated with collecting and processing each unit. It sounds very complex to implement this method, but the good news is that in this method is available in our package called Sampling Strata, developed by a group of researchers from Italian National Institute of Statistics. So we implemented this method on CFS like frame scenario, and in the first step, we imported establishment data, including all their auxiliary variables. Then the frame based on the loaded data is created, that's showed here. Then in the next step, the atomic strata resulting from the Cartesian products of all auxiliary variables is constructed and is stored in a very big matrix. Here is the sample of data stored in the matrix, which includes the stratas and all of the information. So in the next step, we assign the calculated CV to the constraint, and then at the final step, we apply the optimization function to the to find the best generation, basically, and that's minimize the sample cost and CV. So this is an ongoing project, and future work is including applying different other methods like simulated annealing. We are still working on that. Also, we are thinking about combining methods together and comparing that and applying all of these methods to the CFS sampling design and finding the difference. So we will hopefully have some more updates on the upcoming conference in New Orleans for the establishment statistic next year for OCR. Thank you.
Thank you. The final speaker is Sherry Valerio from Tableau.
I didn't see it.
Yeah, just here, I'll get it for you.
I mean, I know where.
Yeah, if we just kind of go down to here.
Oh, you already brought them all up.
And
That is.
that's yours.
Thank you. Yep.
And do you want to put it in
Presentation.
presentation? Yeah, there you go. There you go.
So I'm Jerry Valerio with Tableau. I've been with Tableau for 6 years. So I've worked with data all of my career, business intelligence, data warehousing. I've even done reporting when it was fashionable on the mainframe, so that dates me a little bit. But worked for other vendors in addition, database vendor Vertica, data integration company Informatica, and I've also worked at management consulting organizations early on in my career. So targeted audience, basic knowledge of statistics, and you're new to Tableau. So I will make the case for why visual analysis is a great complement to statistics. Example number 1. So Anscombe's quartet. How many people have heard of that data set? And if you were in the room next door, that doesn't count because I talked about it there. So Anscombe quartet is a special data set. A gentleman by the name of Francois Anscombe in 1973 hypothesized that it is possible to create data sets that look very similar when you look purely at the descriptive statistics and can be jumping to potentially wrong conclusions if all you ever did was just apply descriptive statistics. So these 4 data sets, if you were to apply summary descriptive statistics, actually produce a very similar, if not identical, profile. The mean of X is 9. The variance of X for all 4 data sets is 11. The mean of Y in each case is 7.5. Variance of Y, slight variation, plus or minus 0.003 from 4.125. Variance, correlation between X and Y is 0.816 to 3 decimals, and then the linear regression formula is identical, 3 plus 0.5x. The story is different, though, when you start plotting the information. So when you plot the first data set, you actually see something that looks a little bit scattered and random. That essentially means that the data doesn't really have a strong fit for a line. When you look at it plotted in the second one, Y2, you can actually see a curve expression probably being better suited, and therefore linear regression is probably not the right model if that's all you based it on. The third one is a linear regression with a tight fit -1 data point. And the point there is that one data point can actually skew the data that looks well aligned to produce a very similar profile. And then the fourth data set is also aligned. It's actually a constant. But again, one data point can skew the representation of the data to produce, again, a very similar descriptive statistics if all you did was just do that. So example number 2 for visual analysis. So most of us are used to, and again, I don't want anyone to give it away if you know the answer to this. When we're looking at data and we're basically taught to kind of analyze it, our typical tendency is to kind of read top to bottom, left to right. So I'm going to give you, I don't have my phone on me. I'll count in my head. I'll give you 30 seconds, and then I'm going to do a survey to see how many 9s are found in this data. Raise your hand when you think you've already made a determination. Okay, I think there's a decent number of people. The others can continue to count. How many counted 5? Raise your hand. 6, 7, 8, 9, 10, 11, 12. So even just at the very beginning, I already made my point after going to the second one, which is we have a room full of people looking at the same exact data set, yet we came up with numbers like 5, 6, 7, 8, and then after that, it actually fell off. But if now all we do is add, change the characteristic of the data, this would be a much simpler exercise, right? And so the answer is 10. Again, a simple matter of just changing a characteristic of the data visually helps with the process. Why? Pre-attentive processing. Can everyone tell me what's in the field? Can everyone see what's in the field? So this goes back to what we as humans have been conditioned and evolved, right? Hundreds of thousands of years of survival. And one of our biggest means for being able to protect ourselves is sight. So with data visualization, using sight as a means for cognition, things like length, width, orientation, size, shape, curvature, whether or not data is grouped, and even the color intensity or the color hue of the data, all of these attributes can be used to express data in such a manner that you can actually see your analysis, visual analysis, if you will. And that's also the foundation by which Tableau was built on, being able to help people see and understand their data. Another reason why we didn't come to use numbers until late stage once we've evolved. And in fact, there are multiple ways that numbers are used without necessarily consistency. So that is why we have visual analysis as a means, because of our fact that we can use our sight and our ability to discern color, shape, size about data to be able to do a visual analysis a lot quicker and a lot more rapid than traditional methods. That's it.
Any questions?
Thank you.
So I have been directed to remind you all to go to